Hi, this is a lesson for Year 10 Higher Mathematicians. The topic is histograms, and this is Lesson 9, Time Series Graphs. Now I know the topic's histograms, and this is kind of tagged on to the end of this week's lessons, but time series graphs are themselves quite important in terms of understanding graphs and how they work. Right, the time series graphs show the mean temperature and rainfall respectively in the UK over the last 110 years. Explain which part of the time series graph best helps you to comment on any trend or pattern in the temperature and rainfall in the UK. Now this first line graph shows the mean temperature or the average temperature in the UK annually. Now it's important for a time series graph you realise that along the x-axis we always plot time when it's a variable. Now in this particular case we're talking about time being measured in years. It could be months, weeks, days, hours, minutes, seconds, even less than that. Okay, but the key factor is for a time series graph that the time will always go on the horizontal x-axis. Now on every year the mean temperature in the UK has been plotted, and that's been done every year from 1910 up until 2015. And the effect of doing this is and joining the points together produces this jagged red line of ups and downs. Okay, as the mean temperature changes every year from over a 100-year period. Now there are various other bits of information given on this time series graph. We've got here, this is the blue dotted line, is the lowest value achieved over that 100-year period. The red dotted line is the highest value achieved over that period. The brown line reflects the most recent value over that period. So for 2015, okay, that's the one there. And then this pink line here through the middle is the 1981 to 2010 average. So it's an average from specifically from a 30-year period from here onwards. Now, how useful any one of these values I've described so far is up for debate depending on what it is you are trying to find. But if you are after a piece of information that best helps you to comment on any trend or pattern in the temperature over the last 100 years in the UK, it is probably this line here, okay, which is the black dotted line, which is referred to as a smoothed kernel factor. And what this is what's called a trend line based on moving averages, okay, which is something we're going to look at today. So you can see here then, for this line from 1910 through to about 1980, if you look at the moving average, there's not a lot of variation in the mean temperature in the UK. It isn't until 1980, okay, where we see suddenly a very distinct rise in the temperature, okay, up to about 2000, and then it carries on increasing, even though not as steeply. Now if we have a look at the other time series graph, which looks at rainfall in the UK, again, if we look at everything, if we look at all the other bits of information we're given, how useful they are is debatable. But this black dotted line again through the middle, okay, the smooth kernel filter, is a type of moving average. And we can see that the rainfall does actually decrease from 1910 through to about 1975. However, after that time, again, there is a very steady and continued increase in the rainfall in the UK right up until 2015. Now, what we want to be able to do today is draw a time series graph, and in particular use that time series graph to draw a trend line, which we can then use to help us comment on any patterns that we notice on that, that time series graph. Okay, so let's look at this example then. The number of vans rented from a vehicle hire company are recorded below. Draw a time series graph, find the 4-point moving averages, draw a trend line on the time series graph, and comment on any trend or pattern in the vans rented over the year. Right then, so I've already started drawing the time series graph over the page. I'll show you in a moment. All it means is that on the x-axis we're going to have the month, and then we're simply going to have the number of vans hired going up the y-axis, okay, all the way from January through to December. So that's the graph I've plotted so far. I've plotted it from January through to September, and I've joined up the points as I've gone along. So I'm going to plot now October, November and December. Well, October is 27 vans rented, November is 48 vans rented, and December is 15 vans rented. Okay, I'll just join those up to complete the time series graph. But like those graphs we saw at the start, over the course of year, there's quite a jagged pattern here. It's ups and downs. What if I wanted to know how that van rental business was doing? Is business good? Is it improving? Is it getting worse? Okay, is there any underlying trend or pattern that I can get from this time series graph? Well, to do that, I need to calculate the moving averages. So I'm asked here to find the 4-point moving averages. Now all that means is that I'm going to find the average of the first 4 points here. So 9 plus 24 plus 37 plus 16, press equals, and then divide by 4, which gives me 21.5. So it tells me that for these 4 months, the 4-point moving average is 21.5. Why is it 4-point? Well, I could do the average of 3 points, okay, and it will be a 3-point moving average. I could do the average of 6 points, 1, 2, 3, 4, 5, 6, and then it would be a 6-point moving average. So it depends on the number of points you use to calculate your average. For the next one then, I've done the January through to April. I'm now going to do February through to May. 24 plus 37 plus 16 plus 15. Add those all up, press equals, divide by 4, gives me a value of 23. Next one, March, April, May, June. 37 plus 16 plus 15 plus 24. Add all those together, press equals, then divide by 4, actually gives me a value of 23 again. Average for April, May, June, July, that would be 16 plus 15 plus 24 plus 45, press equals, divide by 4, gives me a value of 25 vans. Now I keep on doing that all through the data, moving along one, so the next one value I'm going to calculate is going to be May, June, July, August. I shuffle along one, calculate the 4-point moving average, fill it into my table, and then I can use that to plot my trend line on the graph. So if I just fill in the rest of these now, you can do this yourself and then check the answers are right. I should have 23.5, 23, 23.8, 24.5 and 25.8 if I've calculated those correctly. Now I'm going to take these values and I'm going to use them to construct a trend line on the time series graph that hopefully will tell me how the business is doing. Now the first point was the moving average for January, February, March and April. So I'm going to plot that in the middle here, okay, of those 4 points. So the first point for the first moving average for January, February, March and April was 21.5, which is here. I'm going to put a little X, okay, right there. The next moving average for February, March, April, May, I'm going to plot here in the middle of the those values again. And that was 23. I'll plot that there. The next one was for March, April, May, June. So I'm going to plot that in the middle of the values there, and that's 23. The next one was April, May, June, July. So I'll plot that in the middle there, and that was 25. And if I carry on now plotting those values, it was 23.5 was the next one, 23, 23.8, 24.5, and 25.8, which is that one there. And if I join those points together, I end up completing a trend line. It tells me a little bit about how business is going for this van hire company. So what do I think then? If I was to comment on any trend or pattern in the vans rented over the year, well, I can see that business, okay, is very steadily improving over the course of the year. Okay, we get a bit of a peak here between May and June, but overall the trend line shows a steady rise in the number of van rentals over the course of the year, which is good news for the business. It tells them that very steadily business is improving.